Welcome to Supply Chain Bros, the podcast where we break down complex logistics with a tech-savvy twist. I'm AJ, your host. Today's episode dives into the fascinating world of multi-agent systems, or MAS, which is a system made up of multiple autonomous agents that collaborate to achieve an individual or shared goal. These agents are intelligent, flexible entities that can sense their environment, make decisions, communicate, and take action, all without a central controller. In supply chains, MAS is becoming a game changer. Picture this. Every part of the supply chain, the supplier, manufacturer, wholesaler, retailer, even the customer is represented by a smart agent. These agents talk to each other, solve problems, and keep the flow of goods and data and money moving smoothly. The result? Fewer bottlenecks, better asset management, and faster, smarter decisions. We've got an awesome lineup today. We have Mason, a supply chain expert tackling demand forecasting challenges. We have Ayush, an AI expert specializing in agent-based forecasting solutions. We have Michael, supply chain expert dissecting communication overload and logistics. And Adam, an AI expert championing the autonomous communication agents. So let's grab our coffee and jump right into this. All right, Mason, let's talk about demand forecasting. Everyone in supply chain knows it's a nightmare to get it right. Walk us through why it's such a stubborn problem.
Sure, forecasting demand sounds simple. Predict how much of a product people will buy and stock accordingly. But in reality, there are two huge challenges we fight with every day. First, we've got what we call external shocks. These are things like raw material prices suddenly spiking, extreme weather, trade restrictions, or global health events. With these disruptions, it can throw off even our best forecasts in hours. The tools many companies use today rely on historical trends. They can tell you things like what usually happens in Q4, but they can't react fast enough when something breaks the pattern, like a tweet going viral and driving unexpected demand, or a port closure delaying critical materials. By the time the system catches up, the damage is done. Stockouts, overorders, and missed deadlines.
It's similar to driving using last week's GPS. You're headed the right or general direction, but totally blind to what's actually on the road today.
Exactly, and that's where multi-agent systems really succeed. Instead of waiting for tomorrow's reports, these smart agents pull in updates the moment they happen. From pricing feeds, social media, shipping alerts, even breaking news, each agent is focused on a specific signal. So if there's a major delay at a port in Asia, or rubber prices spike, the agents watching the channel reacts immediately. The forecasting agent updates the numbers. It can even trigger alerts or change the order in real time.
That's a big shift, but even with a perfect outside signal, if your data is still locked up in different systems, you're working with a broken mirror, right?
Exactly, and that's what brings us to our second big challenge. Every supply chain team knows this pain. Your sales data is in one system, your inventory is somewhere else, your shipping updates come in through email, and market intel is in a shared device. So when it comes time to forecast, you're pulling spreadsheets, merging reports, and doing manual workarounds. It's slow, error-prone, and worst of all, incomplete. If you do everything right, you're still missing insights because your systems aren't talking to each other. Companies try to fix this with dashboards or big integrations, but those projects take months, and they're still not fast enough for real-time decision-making.
So you're stitching together data like patchwork quilt and hoping the threads hold.
Exactly. And that's where MAS changed the game again. With MAS, you assign an agent to each system. One agent keeps tabs on sales data, another monitors inventory, third looks at supplier delays or promos. They each specialize and report data on what they're seeing, just the key facts. The central forecasting agent brings these pieces together and runs what-if scenarios like, what if demand spikes 30% this weekend? What if our major supplier is delayed by 2 days? And here's the key. These agents don't need to move all data into one giant platform. They're working with your existing tools, no massive re-engineering required.
Which is huge. It means you can move fast and adapt without needing to rip out your current systems or wait for another 6-month IT project.
Ayush, do you have real-world example of this in action?
Sure. Fast fashion retailer Zara leverages a form of MAS for near real-time replenishment in its stores. Local agents on each store track sales and inventory every hour, while regional agents track social media buzz on emerging styles. These pass insights up into a central agent, which fine-tunes reorders and shipping schedules. This decentralized agent-driven forecasting has reduced Zara's lead time from design to shelf by 50%, cutting stockouts during peak trends dramatically.
Amazing. So let's recap. External shocks like global events or market swings can wreck forecasts overnight. MAS gives you a way to respond to that in real time. Siloed data keeps you guessing with only part of the picture. So MAS agents can collaborate across systems to fill the gaps and update forecasts fast. And smart, adaptive, and no more duct taping spreadsheets together. All right, switching gears. Michael, logistic operation generate an avalanche of emails, calls, and spreadsheets and approvals. What makes this problem so painful?
AJ, all it takes is one late shipment. The carrier texts, the warehouse emails, procurement calls finance, and then customer service updates the retailers. There's all these layers involved. So now you can multiply that by hundreds of exceptions every day, with paperwork involved too, different delays, reroutes, damaged goods in the supply chain. So humans kind of struggle to coordinate all these different threads across time zones and different platforms for communication. So you can kind of see how this might create those delays that are costly in the supply chain and a lot of downtime.
Wow, sounds like a communication jungle. How can AI agents prune that undergrowth?
I've seen a little bit of AI stuff for logistics communication, but I would love to learn more. I know there's systems now where an agent will watch your emails, and like another will watch your chats for your TMS, another will listen for your phone calls. I'm not exactly sure what it can do from there though, so I'm looking to learn about that.
Yeah, so multi-agent systems really shine here, using intelligent autonomous communication. So they transform unstructured messages into structured task events. So, for instance, the task orchestrator agent would be a coordinator agent that triages events. So a delay message would generate a reroute request task, which is assigned automatically to the appropriate carrier agent. And if approvals are needed at that point, it routes the task into your workflow tool like ServiceNow and pings the right stakeholder via Slack or SMS. And because agents handle parsing, prioritization, and delivery, humans only intervene on exceptions or escalations, dramatically reducing email volumes, often by 70 or 80%.
I'm curious about that edge case you mentioned, where a human needs to intervene. How do agents know when a message needs human judgment versus kind of when they can act on it autonomously?
It's a good point. So agents use confidence thresholds proven by NLP models. So if the intent classification confidence is above, say, 90%, they will execute on whatever action is correct. And below that, they flag a human. So over time, with feedback loops, the models learn to raise that confidence floor, further reducing manual handoffs.
Can you give us a concrete case study?
For sure, yeah. So DHL implemented an agent-driven smart dispatcher. So when a shipment update arrives, whether via EDI, email, mobile app, agents extract the key details and check rules. For example, is this perishable? Is it on a critical route? And if it's a routine reroute, the agent automatically books an alternative carrier, emails the driver, and updates the TMS. So human dispatchers only see truly exceptional cases, cutting their workload by over 60% and reducing average response times from 2 hours to under 15 minutes.
All right, thanks to Ayush, Michael, Adam, and Mason for sharing your insights today. If you've enjoyed this deep dive into MAS for supply chains, subscribe to Supply Chain Bros and leave us a comment. And be sure to tune in to next week's episode where we explore blockchain's role in cold chain logistics. Until next time, keep your orders rolling and your data flowing.